So, I am Timo Pyhälahti from the Finnish Environment Institute, SYKE, and I will present you some ideas we have had on crowdsourcing and satellite imagery and how these Copernicus services could be used to facilitate citizen science, monitoring of the citizens, monitoring the environment by the citizens in a rather organized manner. We will disseminate these materials according with this recording after the presentation, and then and also the slides will be available. Very good. We have a very nice participation today. 17 people. I think it is always good idea to wait a bit until the last comers have arrived. So I would suggest that people would state which kind of institutes, companies, associations, etc. they are from, and there would be a sort of a short introduction and perhaps some statements on what are your most interests on these topics. So I suggest that we could start on this alphabetical order, which you can actually get from pointing at the participants. I think this is mostly in the alphabetical order. So sort of shortly, who are you and where are you actually coming from, and your sort of incidence angle on these topics, why these things might be different. So I guess that Anastasia is the first one, please.
Thank you. Hello, I'm Anastasia Kovtun-Kante, and I'm coming from Estonian Environment Agency, and my topic is marine monitoring, so including this satellite monitoring, and so I wonder how this is managed in different countries and in our neighbor countries. Thank you.
Yeah, very good. Thank you. And Andrew, please. Hello.
Hey, I'm Andy. I'm over at Vincit. It's a software and design company. Yeah, I'm interested because I try to do planet-centric design over at Vincit, and so this is an interesting project. I've worked with Timo recently, a similar project, and definitely interested in citizen participation and how to get citizens involved in sustainability. So yeah, I'm interested to hear more.
Yeah, thank you. And Eda, please.
Good morning, everybody. I am Eda Andresmaa from the Estonian Ministry of Environment, Marine Environment Department, and my interest is mostly monitoring and status assessment. I'm also participating in HELCOM State and Conservation Group, so maybe we can use satellite data and on this eutrophication assessment at HELCOM level also. Thank you.
Thank you. Thank you, Gayatri. Please.
Hello, good morning. I'm just trying to see if you can see my video.
Okay.
Probably not. Okay, never mind. Good morning, everybody. I'm Gayatri from Origin by Ocean. We are a company based in Finland. We are participating in this workshop to kind of scout around to understand how we can use kind of combine satellite data and crowdsourcing information kind of to help us to aid how to find more accurately cyanobacterial blooms in the Baltic Sea. So we've been doing a little bit of work this summer, and we have also used some kind of crowdsourcing platform as part of our company, but we would like to improve upon it. And today we are looking forward to see how we can improve and what kind of help we can get from all the other participants who are participating today, and we'll take it from there.
Very good. Thank you. And Ilona, please.
Hi, good morning. So my name is, the other Ilona.
Yes. So please, Ilona Söchting, please start.
Sorry. So my name is Elena Söchting. I am the CEO of Analytics Paika, which is a small startup here in Vaasa in Finland, and we are developing situational awareness products for marine sector. Currently, we are utilizing lots of public data repositories and satellite data, and yes, crowdsourcing is something that we would like to include in our products and services. Thanks.
Yes, thank you. And the Ilona Vahta, please.
Hello, I come from Estonian Environment Agency, and my work is connected with satellite. I'm from Forecast Modeling Department, and we use satellite information to monitor weather and marine information from space, and also we use this satellite information for ice observations. And as there is certain public interest towards algae blooming, I thought that it would be interesting to listen to this presentation.
Yes, very well. Welcome. So Ekaterina, please.
Good morning. I'm from Estonian Environment Agency, as well as Ilona, and I'm a satellite specialist working with different satellite data. And the main interest to see how you highlight the algae bloom areas in the marine areas, because we looked Sentinel-3 data for that during the summer, and we have a great interest from public where are these areas with the high concentrations of algae bloom, and it would be interesting to see how it's done as automatic detection. So
Okay.
Thank you.
Thank you. So and the next one is Kerli, please.
Hello, I'm Kerli Hauger from Environmental Agency, and I'm dealing with water monitoring. I'm just looking what ways I can use for my work.
Yes.
So thank you.
Thank you. And Kertuli, please, from the project, please.
Hello. I'm not from the project anymore. Now I represent the Estonian Environment Agency.
Okay.
I'm responsible for the remote sensing contracts here to perform national environmental monitoring program. So I hope this seminar will be of help to improve our work. Thank you.
Yes, thank you. Krista, please.
Hello everyone, my name is Krista Allikas and I'm here with my colleague Kersti Kangro. And we are from Tartu Observatory in Estonia, which is a research institute. And we have been dealing with Copernicus data or satellite data for a long time over lakes and coastal waters, and doing the validation, accuracy assessment and algorithm development. So mainly for research purpose. And now we are really very much looking forward how we can use this data actually to be used more in the monitoring system, and also that we can make this data more easily available for the public. So yes, thank you.
Thank you. Thank you. Good. And Lena, please.
Hello, my name is Elena Lebron and I'm from Arctic Center of University of Lapland and I'm located in Rovaniemi in northern Finland. I'm working in a project looking for changes in Arctic terrestrial biodiversity. My own research topic is related to snow and snow measurements, and we have planned a protocol for kind of citizen science observations.
Very good, very good. Then Martin, please introduce yourself and your institute or company. Okay, perhaps later. Then Anna-Riina, could you please introduce yourself too? You're muted still, sorry.
Hi, can you hear me now?
Yes, yes.
Hi everyone. I'm Anna-Riina Mustonen and I'm from Syke too, from Finland. And my role in this EO-CROWD project is to be kind of a test user, for example. I've been going through satellite images in Tarkka and making HISPs and tested if everything is clear to user and if there is something that does not work. Or yes, and also one of my tasks is to create the instruction for users, and my background is biologist and teacher, so it's kind of a good background for checking these phenomena in the satellite images and creating the instructions.
Yes, thank you. So Anna-Riina and me and a couple of other colleagues in Syke will be creating test datasets for you, and there will be tests next spring and summer and so on. So the same applies, of course, not only to Finland but also to some Estonian targets. So you can actually use these things also in Estonia. So the next one is Anu. Please go ahead.
Hello, my name is Anu Norgren and I come from Vaasa, from the design center MUOVA, which is under Vaasa University of Applied Sciences, VAMC. And I have a little bit different angle into this phenomenon because I'm a service researcher, and we have in our institute, we have different kinds of externally funded projects where we maybe contribute with the service design and business model and these kinds of angles. So in that sense, I'm trying to a little bit learn about if we could be a partner in let's say more the user side of this data world.
Yes, very good.
Nice to see you.
Thank you. There will be some comments and developments on this side also, I hope, with the different companies, institutions, etc. we can gather around this project. But we will come back to that later today. So Stefan, please go ahead.
Good morning, can you hear me?
Yes.
Yes, okay, so I'm from Origin by Oceans. I'm a colleague of Gayatri Muruksan. So we're looking into the cyano blooms and using satellite data at this point to track, locate, and monitor the movements of the cyano blooms in the coast and lakes of Finland.
Very good. And Sven, please.
Yeah, hi, good morning. I'm Sven from Tartu Science Park, and I'm the head of operations for European Space Agency's Business Incubation Center here in Estonia. And my agenda here is today to gather all the knowledge I get about the Earth observation, since it's the most popular topic for the young startups to jump in the business incubation, but usually it's the most difficult ones because it's hard to commercialize. So I'm gathering as much knowledge as possible.
Yes. So Martin, I wonder if you want to introduce yourself. Well, okay, thank you. Thank you for your introduction. So coming back to the Sven's topic, this is actually something that we want to assist Perhaps some background on the work first. FPCUP consortium is there to actually support the uptake of Copernicus data and services using Sentinels, etc., for different purposes in the society, both in public sector and in commercial sector, and so on. So what we are here in the EO-CROWD project trying to do is to co-generate with you and with different individual participants and individual scientists methods for engaging people to work on this environmental monitoring issues. And what we want to build is a set of different tools and API services on top of which it is easy to set up company or public sector or crowdsourcing volunteer or whatnot operations concerning monitoring of the nature. And this is not the final presentation. This is the introduction. So this actually means that what we would like from the project side is you to engage and comment on the different topics that we introduce, so that we can actually modify these things while we are developing these ones. You have been staring at this HISP and XEPing for a while, and it might be worthwhile noticing that, by the way, you all can see the screen, can you?
Yes.
Yes, very good.
Yes,
So we will come into these ones, but first some background. I will not go through this monitoring of the environment in general, but I will just highlight one service that is quite popular in Finland, Järviviki, which is the lake and sea wiki platform for contributing citizen observations and citizen information and observations on different locations. For example, the cyanobacterial blooms are there available as people have detected them, and this is also a common platform in which the authorities are reporting their findings, the experienced observers are contributing their findings, and people with no training are contributing their findings, and they are just classified to different classes, so that the sort of the trustworthiness of the observations can be analyzed. And this is more or less the same idea with the platform in behind these activities, because this is well, sorry for having some of the parts of the slides in Finnish, because we are crowdsourcing and we are crowdsourcing in Finland, so we are using mainly Finnish language in these user interfaces. But actually what we are doing in this project is to actually to develop methods for easily interpreting these things to different languages, because this is the interface for submitting information on algae bloom, sinilevä in Finnish. And you might notice that there is a standardized classification of the type and status of algae blooms on a location, starting from no bloom to extreme bloom. This Järviviki is one information platform that we are using for submitting this information. There is another platform for water and hydrology situation related services, more like directed to professionals and sort of if the Järviviki is more of a leisure time, this vesi.fi is more of an information platform, which is also for serious business, so to say, that people, when they have problems with, for example, getting enough water from the wells, are actually using this same source of information. And this system has also a map service. and it has also this omat havaintosi, which means your own observations. And similar observations are transmitted, and you actually notice that there is the same category for the algae blooms in this one than the other one. And this is not a coincidence. Behind these systems, there is the API interface system for actually gathering and disseminating the observations which are coming from these different places and putting them all together and disseminating as one data set of observations. And this is not limited to water-related topics only. This is also used, for example, for monitoring biodiversity issues. There's fountains and such things on the nature which are being observed. And this is not just observations. This is also a place in which reports can be submitted by, different sources, so that, for example, if there's a water renovation work in some river or in some lake, a notification that, okay, this kind of a work has been done in this location is actually submitted to this same system and taken out further in the information processing. So we have an open data system. All the data that is provided in here is basically open and classified or secret data can also be handled, but this is not the primary purpose. This is the key thing is to have an open platform for these kind of environmental activities. And what we have is actually an editor for these API services, so that we can very easily publish new services for these other services, so that we can actually state that, okay, this kind of a questionnaire is needed for this topic. This questionnaire has just one question, but there can be 20 or more in a single questionnaire for one topic. So this is a very flexible system, and it is also designed to facilitate annotation so that you can actually comment an earlier observation that, okay, this is something that should be, for example, be taken out of the open data because this observation or notification is wrong, it's not correct, or it actually, or for another reason, it might be, for example, containing some secret data that should not be actually in the public, for example, personal information or something like that. So we are also focusing on setting up systems which are GDPR compliant, so that we actually are able to gather anonymous data, but there is methods for cross-referencing who the original submitter was if this information is available. Then what we also have for this thing is the connection to Tarkka. I guess that most of you have heard of Tarkka system in Finland, of the Syke service for displaying satellite imagery. Is there somebody who does not know it? Okay, good. I will not go into more details, but with satellite imagery, there is one critical part of the operations. We can actually very easily create these pretty pictures which seem to relate, for example, to water quality. But the big scientific question behind that one is how do we validate that what we actually see and detect is something that is connected to water quality changes, and can we detect them accurately? And this is one of the tools for which this underlying platform, which is called CitOpsDB, Citizen Observations Database, but CitOpsDB is the short one. For which this CitOpsDB was developed, so that we could actually pinpoint issues in there and connect these things to so that we could actually use these things as a reference data for training satellite data. And basically what actually happens is that we generate these kind of standard, these kind of services in which we pinpoint things not on the nature and not by locating the mobile phone, but looking at the satellite image and submitting these kind of classified information that, okay, these kind of classes are available, for example, for detecting turbidity. And this has the same capacity as the citizen observation part, that it actually takes these classifications and turns them into numbers. So the first one is 1, the second one is 2, etc., etc. If it's a single selection thing, and if it's multi-selection, so if you select 1, there's +1. If you select the second one, there's +2. If you select the third one, there's +4. So there's the sort of this kind of potential growth in the of 2. So and this one, the next one would be 16 and etc., etc. So 8 and 16 and so on, so that we can actually turn a single attribute or question into a single digit for these numerical things, so that we can actually code in multiple selections. Well, that was a lengthy one, but the key thing in here is that what we can actually get from these things is locations in coordinates, numeric values to be compared as a classification to the different satellite products. And then we can define it so that we can set this actually translates to URL in Tarkka system. So in here you can see that there's a URL to an image in Tarkka, which contains the date and the location of the data. So this is the one. So what this classification actually here means is that we have observed dredging in this location, and here you see the image of the dredging. What actually happened now is something that is not perhaps common in satellite observation, because we didn't create a satellite thematic map of turbidity or whatnot, because the dredging is not sort of continuous phenomenon. There is just something going on in there, and it's neither actually a place or an object. There is a phenomenon in here. So the first thing what we have done in here is that we have observed a dredging action, which is a phenomenon. There's something is going on in this image, and this is something that can be detected relatively easily by trained human eye. So what the people in for example, in Syke, where there is experienced people looking on satellite images, can easily pinpoint that, okay, there's a feature of interest, and we can actually highlight not just the location, but the area in which things are happening. And these things, of course, are something that could be used as a training material for artificial intelligence systems, so that now we can actually generate a set of training data sets and sub-images on which the AI could actually learn to detect where the dredging is. This dredging is just one example. There's plenty of other things that you can actually detect in these images, which are of this phenomena-like, in which it is actually very difficult to say where the boundaries of this dredging is, but you can actually see that there it is being happening. And Then there is the other topic on this one, that we are not doing this thing just for fun, but there is going to be some actions taken on these ones. For example, it could be possible to actually start checking if this dredging is compliant with the regulations it was given, so that if it has correct permits or not. And there could be reactions for these ones, and reactions are often either new observations or some kind of annotation or decision or report on action, so that we can actually do a similar kind of basically answer a query that, okay, now there's a dredging action. Did we check and find that it has had the correct permits? Yes, no. This is a potential path of action in these ones. One action triggered by another. So now you have examples of this highlighting phenomena of interest and crowdsourcing actions based on the phenomena of interest. And basically the whole thing rotates around the definitions done in the SITOPS DB, in which people are told that certain actions are expected in a certain area after, for example, this kind of dredging pinpointing action. And why we are calling this thing crowdsourcing? Because all of this is done in the open data. So basically, not only the people in Syke could submit the HISP observations. It does not even have to be a human. It could be a company which operates artificial intelligence system for detecting and pinpointing that, okay, now we again detected in one single image something worth looking at. There's a dredging action, for example, and now it is important to react to that one. And they could be trained individuals in these companies. They could be experienced observers. They could be curious volunteers who are reporting that now there's actually something interesting happening in my lake. So please have a look on this thing and see what it is. And then because all of this is done in the open, we can later on analyze what was detected, if things were actually of interest, and we can also do this kind of a reanalysis, because one of the key things that is often overlooked with satellite imagery and satellite services is that they are essentially basically a time machine. You can go back to the point in time, for example, in here, September 2nd, 2020, to look at how the situation looked like in this water body area. And if we detect this thing later, we can actually also launch actions of interest later, but connected to that specific date and time. There is services which are interested in current situation and even a near future situation. For example, trying to pinpoint where to look for measuring algae blooms, interesting and important thing for the point of science. This is another topic, and it is often looked into, but also this analysis of what actually happened is very important, because actually, for example, both the Finnish and Estonian administrations are asked to submit reports on water framework directive, etc., etc. And that basically means that we must analyze these 6 years of data and see what actually happened in these water bodies during those years. So you can well do these things also later. So everything in the world is not near real time. Something is, but not all. So this time criticality is a thing that we have been working on for this XEPIN part. So at this point, I would like to ask if there's some imminent questions. Please raise your hand in the Teams if you want to speak up. It is very difficult sometimes to know if people are sort of following up and if you are too slow or too fast on your explanations when you are doing Teams. So I will take these kind of short breaks when I'm explaining. So we will start with the HISP. This is something that we have rather good already data sets available, and this is been implemented into Tarkka user interfaces for showing what and where things are happening. And the idea is to use the Tarkka in the first stage to pinpoint the data of interest and features of interest, so that we can actually do some kind of a preliminary interpretation or final analysis on what is seen on Earth observation data. The key thing, however, on this thing is that you are not actually bound on Tarkka, because we are working on these API interfaces. We have extended the Open 311 sort of recommendation for this kind of exchange in between administration and the society of the sort of the slow moving data, and adapted that one to these kind of purposes that we are working on. And this basically this second point means that you can actually develop your pieces of software or your chains of actions, etc., on the services of the CTOPS-DB. Basically, CTOPS-DB is also available on open source. In practice, currently, it's very difficult to actually set it up from these things, because it's not documented well and so on. So what we are actually also in this project and what we want to find out, if there's people who are interested in, first of all, creating these kind of applications and services, and then if there might be even people who would like to set up a system of CTOPS-DB for themselves. We in Syke are happy in this stage to accommodate almost all types of things in our own CTOPS-DB service. The trick is that the CTOPS-DB service defines what are the question sets and topics of interest. So if these things are of interest to Syke, we are very helpful on these ones. But I foresee that there might be other types of things that would not be of Syke interest. So this might be also a business case for somebody if these things really kicks off. But what we should currently concentrate on is to actually look into this development of these technologies. As I said, we are still on the development phase on these things, and we want to co-develop these things with other people. So the key thing with the HISP is that we will have a set of data available to say that there's something worth looking at in a particular satellite data product on a particular date and time somewhere. And what this actually rotates around is what we call the center point. This is a new development in the project, so this is still advancing. So what we are actually pinpointing is locations in which this observation was done on an image. And we can base these different CTOPS DB actions based on those observations, and refer to these definitions on what was the view in which the interesting thing was detected, and we try to set this.
Ütles, et sina nõuad mult ühte, Peep lükkab tagasi.
Yes. Okay, now this is how it looks like. There's a center point because all the SITOPS DB data is connected to a location on the ground, and then there is the smaller range and the longer range, and of course the bounding box of the image. So an example, what if we detected interesting phenomena in turbidity, there's sub changes and issues coming from stuff coming from river, we could define that this is the area of interest of our observation, and what we can actually do is to pinpoint the location and crop or reference to this particular part of the satellite data. We now use the true color image, but this could be the thematic map of turbidity or chlorophyll activities, etc., etc. The key thing is that we can have a URL to this one, and the idea is that the inner circle, the inner range, is the area which is at least to be visible on these viewings of this data, because as you actually open this location again in a different browser, you might actually get in a different shape. So the outer limits are the maximum limit of what is actually detected to be of interest, and the inner circle is the area where the phenomenon really is, and it's also the inner part of the feature of interest. As said, these phenomena are difficult to delineate, and sometimes they extend beyond these limits. So we will use these things as to highlight that at least in this inner circle, the observations or the crowd from the same data as from the satellite image, that would be of interest. And there will be interest in the stuff that is within these outer limits, but it's then a bit unclear if it's of interest or not. So this is the most critical observations are done in this inner circle, and then we have one piece of information to which new pieces of information, for example, the classification results from this image can be bound to. And all these things are then referred to this center point. And what actually is well, I highlighted also that some of these images, for example, SAR images, might not be sort of rectangular, but we would be defining this kind of bounding box for them too. And basically, in the later interpretations and applications in the Tarkka, these ranges could be adjustable, but currently the idea is that they are just coming from this viewing area data. And these ranges can then be used for asking for people for more observations on the ground from the things that we have been seeing from the satellite image. And this is the core idea of the HISP. And the idea is that at some stage there will be possibilities for in Tarkka to highlight where the area actually is. And there will be different attributes available on this service of SITOPS DB for plotting these things out, and all these things are in a single service request instance, which can be referred with one ID number, and this ID number can then be used to link the different observations. Even it might be sound difficult, but it is very straightforward for the systems developers to use these APIs and this data, so that they could be developing services based on these ones for mobile applications or web applications, or as a pieces of process in the in their activities. So I've spoken already a lot. So do you have comments or questions on this one? Not yet.
Do you have any maybe user guides in English where user can do something like that?
Yes, this is something that we are working on in the project. There is a Finnish instructions in kansalaishavainot.fi, but this is all in Finnish, and this is something that we will look into in next year. This is a co-creation process, and we will create this documentation as we create the system.
Okay, thank you.
Yeah. Currently, there's only limited things available in English, mainly in these presentations and also in this recording that we are currently making. Good. More questions? I could actually go to the next page, explaining about the XEPIN, about the actions that we are actually working on. As I said, HISP is about telling people that there's an interesting satellite image somewhere with an interesting phenomena, which has some kind of already descriptions or classifications or information. And these kind of things will be done from cyanobacterial plumes, turbidity events, and certain cryospheric events, most likely melting of ice on the lakes and changes in snow cover to some preliminary extent. And the idea about crowdsourcing is that somebody actually would respond to these things by providing us in situ on location information of what is actually happening. And what this XEPIN is all about is to actually submit requests for the crowd, from the crowd and for the crowd on different topics. As again, this is an open system, so people could themselves set this kind of XEPIN chains of actions. But in the first stages, we will do it in Syke, and we will see in the end of the project if there's interested parties to work on this one. So what is the intention of the HISP is to observe at location the event which was reported based on either the true color images or thematic maps from the Earth observation data. Then there is a potential for reacting to these things, so that if there's a dredging action, somebody will check this detection and see how it actually, if it's with licensed or not. This is a scenario for the future. What we will do in the coming spring and summer is, for example, for the algae bloom, to set up system in which this kind of requests will ask people if they can actually spot the same thing on the location as was detected in the satellite. And the third one is to check for duration of observed event, even if Earth observation data is not available. Because as you understand, we are for very many topics using optical images. We are in low latitudes and there is often very much clouds. So the phenomenon duration might be actually not visible because of the cloud cover. And with this XEPIN change of events, we can actually organize it so that there would be after a while a new interest for people to react so that they can actually check if something is available 2 days or 5 days or whatnot after the observation. So the first one is rather straightforward. For example, to verify on location if algae bloom exists in Lake Peipsi, for example, or if it's something else that is there in the water, if it has been confused, for example, to pollen or something like that, which might sometimes happen, especially with turbidity. Then this thing would be used for validating Earth observation results and helping develop new Earth observation products. And as you understand, for this topic, we would need data to be coincident with the satellite observations. So there's what we call a validation time. It's the time during which we would need as many observations as possible, and at some other times this interest is lower. So what we have done is to develop a concept called seurantakiinnostus, monitoring interest. We marked it with S, which is metrics from the provider side to tell how interesting it would be to get new observations of a certain topic or new announcements of a certain type of a certain topic on a certain location on a certain time. So at this validation time, we would like to invite as many people as possible to actually submit information of if there is a bloom on the lake or not. This time would be something like half a day. In good cases, we would like this validation data to happen in a couple of hours, in 2 hours before or after the satellite overflight. So basically, you can actually set these things in advance if you have forecasts of what is happening and where. So the following time is the similarity time, which means that it is almost the same, but it's not good enough anymore to validate the satellite image because these, for example, algae blooms can disappear from the surface quite rapidly, and the situation will look a lot different. Or if there's a snow melting or ice breakup situation, the things might actually change over 1 or 2 days very significantly. So this might be the similar thing, but not quite. And then the third phase in time after these two is the reobservation time, which I already mentioned, that we would actually ask people to go on the location again to check what the status is. And basically, if new observations are used to trigger this chain of Xepin events, when there's new observations at the reobservation time, we would actually again enter the validation time, which means that we would start the sequence again. And now you can see that it could be possible to set up these kind of a periodical things to work on. And basically you can also assess the quality and the value of the gathered data set on this one. And because seurantakiinnostus monitoring interest is actually a figure, a floating point number, which can be converted to points or whatnot. So it can be used for these kind of serious games, events, and so on. So the thing can be actually used to sort of value which is the achievement on a certain location, not by an individual, but rather of the crowd on that location. Actually, now could be a good time for short set of questions. Please go ahead. still no questions. Perhaps I'm speaking too slowly. So then a couple of requests on the requested actions, so that what can be done with the SITOPS DB system is that we can use the HISP observations for starting these activities, but it does not need to be satellite introduced activity. It can be the vice versa. It could be that somebody is requesting analysis of Earth observation data if there's an in situ observation available somewhere. And then this could be used also to highlight that, okay, in this location, observations should be gathered. So as I explained earlier, there's a location and a range, which can be very easily converted to an area in different geographic information systems, so that we can actually ask the people to do something on the location and provide them information that, okay, in this area there's these kind of interesting things to do. And as said, all requests visible and available for everyone looking at the APIs of the service. So the open data is available for everybody, and people could react to these things differently. And then a different point is also that there is the action does not need to be observation. So this could be actually a request or an order to do certain things, because we have the pseudonym thing and the API ID. So even with open data, we can actually submit information that the receiving end can actually interpret that this is actually a valid source of commands or calls for actions. For example, there could be a point given in the system and asked that a special kind of Earth observation analysis should be done in this location. And this is it is possible to set up these kind of chains, and it is possible also to set sort of target levels in which this S value has to be, so that this actually is done. So and the events, so we can actually crowdsource and also request services in the same platform. So if in general there's an event of interest, but it has a very low S value, it's something that the people could react to if they want to. But if the high interest is high enough, there could be a triggered action, for example, for a consultant to go to the location to make some observations and measurements and so on. So this kind of things can be set on top of this thing. And basically, as we are talking about the open system, this also creates a marketplace for this kind of activities. So one could actually say that this kind of a system is available for stating what actions would be needed, and the contracts could be made so that if certain kind of orders came from this system, the companies would automatically react for these things, or the officials on the municipal or regional level or whatnot. It could be also used for the scientific work for gathering data on a specific locations. And then one of the key things that I personally see this could be of value would be that if and when there is gaps in the observation data, this could be used to set up monitoring requests of this type for the different locations, so that the people would this would be used to actually fill in the gaps in the data sets, so that we would be able to gather sort of consistent or rather consistent data with from different sources on the same location. Okay, I guess that now there is some questions, or was I too long and precise and everything is very clear? Well, I guess that I was precise enough. So I think that we could actually have a look on some of the services that we are working on. I will first show you this Tarkka view, and there's actions going on in there, and basically we have already some development versions in which there's an additional button from which you can submit some test information, but this is work still going on, and these HISP services will be available for our internal testing during this year, and in the next spring the HISP data sets that we have been gathering are first published, and there will be additional data sets published and data published throughout the spring and summer to show what this thing could be like. And I will not sort of demonstrate Tarkka so much further, but basically Anna-Riina has been going on through different topics. We have already certain HISP examples in here in which we can actually find these different places and get the locations. For example, this was the one that I showed you earlier. So we have some examples already available, and we have also a demonstration of this XEPIN. This is a very preliminary presentation and example, and it is, as you see, it's currently being used. And for example, in these locations, it states that this is the need of a new observation is big, great, suuri, and it actually states in here that it's currently in the stage of re-observation. As you see, and actually from this one, from the implementation of Avoin RY and Avoin Map OY, you can actually see how it actually could work in practice, that we have some areas of interest highlighted in a data format, and then ranges around these places which are submitted, and then these locations are the areas in which the things could be are requested to be done. Well, this is not exactly a Pokemon Go on the environment yet, but you can easily envision on how the different topics could be differently scaled and highlighted. Different locations of interest for observations would be highlighted. But there's also another point of interest I put to here. There is actually 2 points of interest in here. There is this combined ice service. So this is a questionnaire for making this kind of an ice observation. So it's to report the ice situation in the location. It's been requested from this location. This location, oh, well, disappear, please. So, and the same one in here. Well, the same observation, but this is more like the highlight for the different approaches, because what I just did today as for the test, I put an example that in here somebody had been ordering SAR image on this location, and that this image would have been taken now, and there would have been a detection on, for example, in Lapland, Sodankylä receiving station is by coincidence in this same location. There would have been a point in which somebody is monitoring what's available and what's not, and then there would be a new, not an observation, but rather a statement that there is new data acquired in this location. In here, there's SAR data, and that actually has triggered this kind of monitoring action to be requested. So there's a question from Ekaterina. Please go ahead.
Yes, I like your application. It's quite attractive. But I would like to ask you about the observations. The one type of observation is a water quality, as I understand.
Yes, yes.
And is it performed by specialists or volunteers?
Currently, we are working on setting up the HISP database from the specialist data. And the big idea for next summer is that there is going to be these kind of specialist observations available of the situation on the area. However, from this data, you can actually pinpoint from the API ID the source from which this is coming from. So basically, other partners and not just Syke could be able to send HISP observations on the location. One key thing with crowdsourcing and with this kind of open work is that there is information available, and there might be some annotations on the quality, but it's always the responsibility of the receiving end to actually decide what they do with the information, if they trust the information or not. There's the old joke that there's a citizen observation of a tiger in the city street. This typically is very wrong, but sometimes this is very interesting and very important. And there is no way in before to know and to find methods to say that this is the time in which this is the right information. So what actually happens is that information is being provided, and then you might actually choose that, okay, this is information provided, for example, by Syke specialists, and I will react to these ones only. Or you might decide that, okay, I will actually take on board all the observations available and see what I do with the crowdsourcing data.
Okay, and ICE observations are, is it some kind of mobile application or?
Yes, basically, for example, this one which triggered this observation is coming either from, I think it's coming either from Järviviki or from vesi.fi. These interfaces I showed in the beginning of the presentation, so that there's some information provided on this location.
Okay, very attractive, very interesting.
Yes. Okay, and now we have a second question by Ilona. Please go ahead.
Yeah, hi. Yeah, this is definitely very interesting, and some of my question has been answered right now, but another aspect, when you are saying, okay, requesting an observation, and you brought an example, for example, the SAR observation, what type of observation facilities do you mean or are accessible?
So
is it just the free, like, Copernicus data or?
Please pay attention. These are demonstrations. So this is not an actual image of the SAR. It's test. You see, it's test.
Yeah.
And the idea behind this system is that there is a platform on top of which you can build new services. So this is rather a methodology than source of information or activities. What we have for using these things is, for example, this Tarkka user interface, in which these things could be spotted and pointed out and then done by different operators. And then how people would react for these kind of observations. You could ask ICE for satellite image, and they would say yes, but it costs you rather much. The rather much is, I think it's not a secret that it's perhaps more than 10,000 euros an image or something like that. So I recommend that you would have a really strong system set up based on these. I will shortly show you something when I get this. This annoying part of the. Now I can press it. What actually the system provides is that there's this kind of defined user interface or this kind of API interface services on top of which you can set up chains of events. This, for example, is the current draft of the center point data for HISP, as I explained. And this is something that is available. We also have available in these pages. There's this kind of this is a public web page in which you can actually see what kind of services there is around, and this I will share this one with you, because from that you can actually find the kansalaishavainnot.fi thematic thing, which is coming to this place too. So basically you can actually from here select the service code and select if you want to see the observations or not. And then what actually it generates is an interface for submitting the citizen observations with the guidance and with the topic, etc., etc. This is also a demonstration in a way, so that to highlight what you can do and how you can set up things like the things that you can see in vesi.fi interface for the own observations. So I hope that I gave you the right correction, even if I didn't answer your actual question of the things.
Yes, yeah. So you basically create like an interface, but not the actual link to observations other than kind of publicly submitted.
I will actually the thing that you actually ask is more like on this specific topic of what are the examples that we have already gathered for the HISP, for example. This is a rather old set of data, but what actually happens is that the operators select the locations in which they point out that there's something interesting going on, and then this one is available as I will actually show you. another thing, please wait a second. This is a report, but actually it highlights what happens. We have a unique identifier for a specific notification from a location. And well, for clarity, I think that this was the number 5463. So this is the water quality estimate, the demonstrator version of the HISP from the earlier days. So what we actually get from this particular information, it has actually highlighted that there is the features are river course turbidity. Features are not connected to phytoplankton events, and then there's also area of darkish brown water, and you have the link to the image. And what you have as in the service is actually a set of attributes which are in a numeric form, so you can actually translate them into different languages. You have the URL, you have the API associated with it. This is a rather bad example in that sense that the pseudonym field was not submitted, but pseudonym is a field in which you can submit, for example, a piece of text with which you can identify in your own systems that who actually submitted this one, and sort of attach the rights and user identification to this one. So you can actually provide anonymous data for common and open use, but you can actually keep the information who actually submitted the data. And with this API either you can actually see from where did the data come from, and from that you can actually sort of find out was it publicly available or was it access limited service. So this kind of information can then be used, and these ID numbers can be used to identify different examples or something that has been annotated. So basically, when you annotate things, you also create this kind of service for submitting the data. And then you will, in one of these attributes, provide the number or numbers for the associated earlier requests for the service or the submissions. So which you can then all marked as not true or to be hide or to be opened up or whatnot. With the API, you can actually access the closed information from your API service yourself. And the API is actually the key thing. API key code is actually the key thing to this one. So if you want one, we are very willing to give you out one for testing, or then we can actually, if you want to use it for real and for real applications, there is free of charge sort of agreement we would make, so that basically which actually says that you try not to fill this system with untrue information and improper information. So that you try to modify and limit the data, and you report the incidents which you want to block out from your earlier submissions. if they are sort of incorrect or something like that. So that you try to limit the number of false alarms from your side. Good. And basically, I showed you this one and this one. Okay. Perhaps some additional points from the XEPIN in the technical sense. So we have these service codes available, which are defining the different sort of the monitoring sites around which the observations are being done. Basically, any CitOps-DB input is available for the core site from around which the monitoring is being done. And then one defines the monitoring interest for the topic. So you set what kind of things do you want to monitor in these places, and then there is going to be a model of the changes of the monitoring interest, the timings, and the percentages or the points for the different things and the durations of these different time phases, etc. You can define these things yourself. We will look in during the project what kind of service we do for defining them, not by hand, but by automated services, depending on your interests and so on. So if there's a lot of different companies or institutions who are interested in doing these things yourself, it is possible, and we will develop it towards this direction. If there's less interest, we will actually define these systems only within SCYKE, and then we will actually set up these services based on these things. And a key thing is that there is going to be defined a new input for the CitOps-DB, which then actually triggers the changes in this monitoring interest, triggers the start of this validation time, similarity time, reobservation time cycle, and actually also defines if this is a cycle or if this is a one-off thing, so if it's to be repeated or not. And there are a couple of XEPIN services which are already available, as I explained in this previous screen. And then there is new developments which we are actually looking into. How to actually indicate actively that there is now triggered monitoring interest somewhere. This might be an easier approach for many of the services, that if there were actual statement of that there's a triggered activity that you should actually calculate points on. That could ease out technical design. And then we will work on this indication of interest to respond, for example, interest of the local persons or local volunteers to monitor a particular lake. So we could actually concentrate on those ones, and even working on these as said levels of monitoring interest to react on, so that certain activities would be triggered as a new Open 311 statement in the CitOps-DB database for this location if something is actually some S level is being crossed. This is basically the short version of what we are doing. As said, we are in the middle of the project. We are working towards the test period of these approaches in spring and in summer. So this event is to show you what is there to come, and you can actually see if you want to associate and test either HISP or XEP in some way in these tests. There's going to be a new presentation of these topics next spring to highlight what is the exact technical output and setup of these activities for the spring and summer. There's going to be user surveys on how interesting and what you would like to do with this kind of stuff. And this survey will be actually presented as along with the test results in next autumn 2022, like the next year. So and there's going to be a end workshop for the project to see what has been accomplished, and the key output of that one would be the road ahead plan. So we are going to be generating some kind of a roadmap of this development of activities, so that we could actually see how we could actually work on these things jointly. And one of the very interesting things I would be interested in seeing, because we have had actually surveys trying to locate some kind of similar activities in other parts of Europe, but we have yet not found any. So this might be that there has not been conferences, so the things have not been presented due to this COVID situation or whatnot, or it's just that it has been going on somewhere else. But as you see, almost nothing has been very particular to water, because you can set these chains of interests up for monitoring biodiversity, working on precision agriculture, working on maintenance of roads, maintenance of this and that for the wind time, or anything that actually can be done with satellite imagery. And basically, well, if you just use the SITOPS-DB, you can set these kind of crowdsourced activities and platforms for very many things. But well, let's see what happens. I guess that there could be some additional questions or comments. There might be also that, well, go ahead, please.
One small question. I wasn't focused totally because did a bit work abroad.
Yeah.
But is it application only work on Finnish area, or might be used for another locations in the future? Maybe.
I will start by the Tarka part, because Tarka is, of course, for the Baltic Sea area oriented. This is more or less the scale where you can actually zoom into the topics of interest, but it is actually possible and feasible to use the same platform for viewing the images elsewhere in the world. So it's not possible to browse the images and find them outside this area. As said, we are, because there's not gazillions of observations and activities, we are happy at this stage to host the SITOPS-DB for this Baltic Sea area, and all the Estonian activities are very welcome, and perhaps also other ones in this area which are feasible to be organized. And basically, we will take this approach that because currently the workload is not overwhelming to manage and monitor and etc. of the data, we'll have it open, and if there's going to be a problems, we will actually implement cures for these things.
Thank you.
Yeah. Good. And as said, I would guess that there could be room for European cooperation in these kind of activities. I actually did not show you one thing because what I have currently done is to actually set up a system for reconfiguring these user interfaces, because I was thinking that how do I actually set up Estonian interfaces for the texts to be displayed, etc., etc. So there is statements available which actually contain these definitions in different languages. So we can actually also broaden the language part, but not only that, we can also submit additional sources of information for configuring different services openly, so that a service could, if it does not want to set up this type of a very elementary user input, it could actually take some additional input from an additional configuration source URL somewhere for adding into a specific service code. That is the data submission service in the API interface. This basically means that the system is extendable and translatable, so that you can actually translate also yourself the different language user interfaces and systems. So as said, there is currently no comparable European system available, but it would be interesting to see if we can actually work on that one, or we could, if somebody is interested, to work on, for example, on HEU proposal to try to sort of streamline and make this more public approach, so that there would be sort of common European service provision of this kind of services, because some of these things are national, some of these things are regional or even local, so it's not very necessarily very top-down issue to define these things. Good.
Thank you very much, Timo, for this presentation. I was just wondering to ask about your plans or vision with this service. Like, do you see it would be most useful for monitoring agencies and people responsible for reporting the status of the environment, or do you see it would be more beneficial just to attract citizens to do the monitoring in their own areas and just to be more aware what's going on in nature?
Yes. Well, that's a good question. And why SYKE and I are doing these things is that SYKE, among other these kind of organizations responsible in setting up monitoring in Europe and so on, we are interested in citizen science, and there's very big contribution of different topics from citizen science on, for example, ornithology. For other topics, there is less data available, and some of the data is not feasible to be used. And my job in SYKE is to turn these observation methods more popular and more effective. And this happens with two approaches. First, we will attract citizens to these kind of activities with different things. And the second one is that because this is a crowdsourcing thing, we are not doing everything by ourselves, but we are enabling people to contribute. So basically, that's why we have the open APIs for companies and associations and different other institutions to work on the data and with the systems so that we can jointly build up data sets of quality and control the quality in a crowdsourced manner. And we can work with the different associations, different companies who have different services for gathering the data. Because as you see from the point of technology, there is the API through which you can actually send data to Syke, and with the API key code, and with the defined set of information. So what we can do is to actually set up services of data reception for different types of questionnaires which are not originally done by Syke. So we can co-work with the different organizations who are also active themselves gathering data. So it's actually sort of a both and. Gayatri, how do you actually pronounce your name?
Hi, Timo. Gayatri. Yeah, that's right.
Gayatri.
Just a little bit of a practical question. What is, for example, if I take just to ask you a rough number of what is the level of participation from the crowd? For example, this summer, how many kind of alerts did you get? Let's say, is it like in hundreds or thousands?
It's in thousands, but not in tens of thousands. There's hundreds of thousands accesses to the Järvi-wiki. Currently, actually, I don't know about the vesi.fi because it's rather new service. So I don't have the data on that one. There's thousands of observations submitted on different topics. Water quality is perhaps the most hot topic. But one of the actually things why we are doing this thing is that we would like these numbers to be higher. So one of the things to get more data is actually to ask for these things. And this XEPIN is actually method of asking people to do and directing what could be of interest, and please do this and please do that.
Yeah. Do you have like normally, like, is there some kind of a system where you have like the like, for example, active participants? Let's say there are like 50 people, southern part of Finland, who are like actively participating every summer. Do you have these kind of some kind of grading system or some way to assess, like, are there like very active people, and kind of getting them in a way to get them involved a bit more if they are really interested?
Yeah, there's SitOpsDB itself does not keep track of the people. It's designed for the anonymous use, but Järvi-wiki does. So the platform in which these things are being done is they have different ranking systems and activity systems and so on. I think they are. I'm not the person who is actually running this thing, so the Järvi-wiki. So I'm not actually sure if it is even possible to get this data outside. But typically these are limited to within system activities. Yes.
Sorry,
but,
could you refer me the person who is doing this Järvi-wiki?
Yes. Matti Lindholm is working on that one, and further questions of Järvi-wiki could be pointed to him. There is actually data is being stored to Järvi-wiki and then to copied of these certain topics to SitOpsDB for this centralized dissemination of these things. And we are in different approaches and different activities looking into methods of using Järvi-wiki as place where, for example, we could actually point out where the interesting stuff is, or if there's new activities. For example, we are active on marine litter issues and lake shore litter issues and these kind of things. So how to integrate those ones in such a manner that this information is then disseminated through openly also for the data access systems.
Okay.
Yes,
Just one more question.
yeah.
I'm not sure if I really understood you correctly, but is it that the data from Järvimeriviki and Vesi.fi are they kind of combined together and you're kind of archiving them?
Järviviki is a wiki system, so there's sort of a wiki page for page for different stories or images or activities on a lake, and a subset of these things is stored in GitOps mainly the observations which are being made, and then they are done in here. Matti has been doing different technical approaches on that one, so he has also been working on similar kind of widget approach for the havaintolähetti, the tool for submitting the information.
Okay. And do you kind of over the top of your head have an idea that sorry, I'm asking a lot of questions, but I'm just interested. So like so do you know on top of your head that how many years of historical data do you have on Järvimeriviki and all of this, crowdsourcing information?
Yeah, the crowdsourcing information. Now Järvimeriviki is about 10 years old, I recall. So there's a lot of data already in there. But then there is, as people are able to write their own stories, so it's dependent of the lake area and sea area of which we are talking. So there might be information which is not submitted through these observation submission systems, but rather in the texts or in some documents attached and so on.
Okay. Thank you. I think I have a lot of answers now. Thanks.
Yes. There's one topic I could also mention that, as said, the CitOps-DB data are openly disseminated also as geographical information. So we have one layer of data which is actually disseminating all the attribute-related data. So if you have an ArcGIS or ArcGIS Online or QGIS, you basically can attach to those observations directly as data. So you don't now have to make any adaptations to actually work on these kind of data, which is of the Open 311, which is less supported by different map systems. But there is, I will actually put it to the display. There is this observation information which is available as GIS data. So they will contain the lists of what was the service code. So the type of questionnaire, the code refers to the attribute or the question in hand, and then depending of the question, there is numerical values or integer values for these things, or text URLs refer to the images that are being submitted through this system, and so on. So, but one thing should be kept in mind. We are inviting people to co-development of systems. So the systems are in some stage minimum viable product might be a good term for these things. We have started these activities rather recently, and we are developing these things in different projects. And within this within this EO-CROWD project, there's some additional development, some demos that are going to be made basically merely for the XEPIN things or for action things, and we are perhaps doing some stuff also with consultants on this HISP part, so that the development of Tarkka for certain things and so on. But what we are looking for is cooperation on different projects for using these things, and also using the other rather vast sources of open information from SYKE for the Finnish areas, and for the Baltic Sea areas, and for the satellite data that we have already in this open domain available from the open interface services for map data and so on. So we would be interested in different projects in which we can develop these things further. And then if you want to use certain level of activity in different work in which you are working with, then you can we can actually make some kind of agreements on what and how it is available. Basically, everything is available as long as SYKE is working on this thing. We are a government organization, so basically, in principle, this is forever. But if there's a new parliament and decides that, okay, this is not what we do, then we will stop, but we will give you a fair warning before that. And as said, there will be also this line, if somebody would be interested in providing this as an open source software and to maintain these kind of databases, that could be an interesting avenue to look into in different cooperation projects. Good. So I wonder if there's additional questions. I think that we should stop to this slide pointing out that you can contact me personally, or perhaps also this kansalaishavainnot address, which is for the technical service maintenance of SYKE. There's actually another one, havaitsemaan@ympäristö.fi or syke.fi, which is intended for private citizens and different associations organizing these activities. So we have a sort of a chain of providing the services in here, so that there's these two main contact points are available in Finland and other countries than Estonia. And Krista Alikas is the contact in Estonia for specific questions on location and so on. And we are working with the Tartu Observatory people to work on these things, on the water quality related topics and so on. And if there's tricky questions, I will be always available for you to answer. So it's perhaps the fastest one is to contact me directly. I will just write the address for these citizens and volunteers for your information to this topic, and you can think of the last questions before we end this public session. So this havaitsemaan@ympäristö.fi or syke.fi is also available. They are for the private citizens for user guidance and training, as a backup, the idea is that we would be working with different services and associations and projects and so on, which mainly would tell people how to work with the systems or how to make the observations and so on. But if there's need for backup, the Havaitsemaan is there available, and we will have a in a couple of working days there will be some kind of an answer from email. So this is not an all the time online address, but okay. If there's no additional questions, I will close the session. And before one last announcement. So I will send you invitations for the forthcoming workshops, and you can then decide if you want to join in or not. But please send feedback and send comments on what you have been seeing and how you would be like to participate. And I would be very happy to help out to find sources of funding for you to work on different things and so on. And we can actually look into different projects if there's room for activity potential. But basically, what we want to have is a crowdsourced system in which there's activities around the place which are not fully dependent on Syke funding. So with this closing words, I would like not just to thank European Union for funding this project, but also I would like to welcome you for the discussions. And I will close the public session now.